Alright, in this video I will go over some updates made to ReqPy. There were some minor bugs on the lines of the plots that the code generated that were fixed. I updated the numerical integration routine since the previous one was deprecated by scipy. Also, the routine used to generate the response spectra was optimized, so now especially the single component version runs faster than previously. The functions now automatically saves the plots and the text files with the motions generated, and there was some optional detrending added to the baseline correction routine. So I will go over the new stuff only, so if you are a new user, please go and watch the first video and then come back here. So let's start with the first example. This is the same example from the original documentation where we match a single horizontal component from the seed record to a target spectrum using this function ReqPy single. So what is new is these two parameters, these two new optional parameters, p-order and name out. So in p-order, you specified the order of the polynomial that you want to use to detrend the signal, and obviously this will only apply if you specify baseline correction. So if baseline is equals 1, then baseline correction is performed, and now it also performs the trend using a low order polynomial, and then you here specify the order of that polynomial. In this case, or the default is -1, which means that no detrend will be performed. And the other parameter is name out, and here you specify a string. In this case I'm using the name from the record that I'm loading, but you can specify any string. Let's change it here to any string, like my output, for example. So that's a string that will be used to generate the output files. Okay. So let me run the code. Let's first specify baseline equals to 0. So we are telling the code not to perform baseline correction. If we run the code, then after he finished with all the iterations, he will tell you that baseline correction was not performed and show you the errors for the matching. And as before, you will see it generates two figures, one with the time histories and another one with the response spectrum. What is new is that if you go to the folder where you are running the code, you will also have these figures automatically saved, the time histories and the response spectrum. Okay, and in addition you will have this text file with the compatible record generated, so you can use it directly in OpenSys or whatever software you use for your seismic analysis. Let's now, if we go back to the time histories, you see that it needs there are some drifts here in the displacement. So let's apply some baseline correction. So to do that, we specify baseline equals 1, but I want to keep the polynomial order in -1, so no detrending will be performed. And then once we run and check the new displacements, let's see. So now it's telling you that it performed baseline correction using the first 2 and the last 2 seconds of the record. You see that the error remains almost the same, but the displacement history improved substantially. So that's it. So the detrending is not needed in this case. So I recommend you do the same. I mean, try first to, as we did, start with baseline equals 0, because in theory the approach we are using doesn't need baseline correction if the seed record has already been baseline corrected. But because of the numerical approximation, sometimes you see this kind of drifts in the displacement. So the less corrections you made to your record, the best. But let's see here, if you still have problems, then you can start playing to see if it works, specifying some detrending, some low order polynomial will not go larger than 4, let's say. If we specify 4, then it will subtract 4 order polynomial from the acceleration record, and let's see if something happened. Not much change it, so it's not needed in this case, so just keep it at -1 here. Okay, so let's move now to example number 3 from the original documentation. This is the one where we perform matching of the 2 horizontal components to a target RotDnn spectrum. Remember that whether you use a single component or RotDnn matching depends on your design or your target spectrum. In this case, the target spectrum comes from ASC7, so by definition it's a RotDnn spectrum, so you need to match both components to get that spectral match. So now we use ReqPy RotDnn function, and just for the ReqPy single function, the only thing that changed is that we have these new 2 parameters, p order and name out. So let's execute this. So again, the code generates 2 figures, one with the time histories. This time we have two components, so we have 6 time histories for acceleration, velocity, and displacement for each component, and we see that the resulting record is quite similar to the scale version of the seed record. And the second plot with the response spectra. Remember that this is not a component response spectra, but a RotDnn response spectrum. Okay, so we see that we get a very tight match. And just as before, if we go to our folder, we see we have 2 figures saved, one with the time histories and the other one with the response spectra. And now, since we are performing matching for the 2 horizontal components, then we have 2 text files, one for each component. Yeah, we have one text file for each of the spectrally matched components. So that's it for this video. I hope it's of any help. If you have any question or recommendation, just drop me an email and I will try to do my best. Have a good one.